Hi guys, welcome back to my YouTube channel Learn Code with Nav. In the continuation of our interview series, today I came up with a very popular question in the interview, that is solid principle. Let's take a pause here and think about it and come back again. So what is solid principle? S stands for single responsibility principle, O stands for open or close principle, L stands for Liskov Substitution principle, I stands for interface segmented principle, and last but not the least, D stands for dependency inversion principle. So what is basically about S, which stands for single responsibility principle. So single responsibility principle is nothing but a class should have only one reason to change. Single responsibility principle says a class should have only one reason to change. What does it mean? Let's say we do have a class invoice. It contains three methods. One is calculate price, other is print invoice, and last one is save invoice. The purpose of each and every method is different. Let's say we do want to calculate the price of the, so we need to perform operation in this method. Let's say I want to print the invoice, so we need to write the logic here to print the invoice. And similarly, if you want to save the invoice into the DB, then we need to write the logic here. So does it satisfy single responsibility principle? My answer is no. Single responsibility principle says a class should have only one reason to change. Let's look at this code. Do we have only one reason to change this class? No. If my requirement is today we are calculating the price by item into quantity, and maybe in the future we are calculating price by item into quantity minus discount. Let's say we introduce discounts coupon on our application. Now new price will be calculated on the basis of this one. Let's say I want to change some logic into the print invoice. What print invoice message previously doing? It is printing the invoice. Now my requirement is I just want to change the look of the invoice. I want to add one QR code into it. So I am writing code for QR code, right? And I'm using that QR code in my invoice. Now let's say previously I'm saving this invoice in the DB. Now my requirement is to save invoice into file. So if my requirement is changing, the reason also increasing, right? But single responsibility says no, a class should have only one reason to change but not multiple. So this is a violation of first principle, which is nothing but single responsibility principle. Now the very next question come up in your mind is how we can achieve single responsibility for the similar code. Okay, no need to worry about it. Just like this one, let's say I have created one class for calculation. The name of the class is invoice calculator, and this calculator class contains only calculate price method. So whenever my requirement changes, I just need to modify only this class, and I do have only one reason to change invoice calculator is to calculate the price. I do have created one more class, that is invoice printer, and we are writing print invoice method in it, and we are writing logic to print the invoice. In case if any requirement or any logic change for the invoice printing, then this class is only one reason to change the class. Similarly to for invoice now, let's say we are only making changes in this method when we are saving the database into DB. So this is following the single responsibility principle, which is nothing but a class should have only one reason to change but not for multiple changes. Let's go into the second one. What does open and close principle says? Open and close principle says software entities are open for extension but closed for modification. What does it mean? We are saying the software entities are open for extension but closed for modification. Let's say we have created one class, right? Invoice now. What we are doing is we are saving invoice into the DB. Instead of saving into DB, I want to store into file. So instead of writing same method in the same class is violation of open or close principle, as it clearly said that your software entity is closed for modification. You can extend this one, but you cannot do modification in the class itself. So what we can do is, instead of creating same class, what we can do is we create one interface. Let's say interface invoice tau. What this class will do is it will implement invoice tau and give the logic to save the invoice to DB. Similarly, same interface is implemented by file invoice tau, and we are overriding the save method, and we are writing the logic to save invoice to a file. Did you get it? If not, then I'm summarize again. Open or close principle says any software entities are open for extension but closed for modification. Let's say we have created one class, and we do have a method of save invoice, and the purpose of this method is to saving the invoice in the DB. Now my requirement is I want to save the invoice into file. So what I'm doing is I'm modifying this class, which is violation of second principle of solid, which is nothing but open or close principle. So instead of writing this code, we can write similar code by using this approach. We can define one interface, that is invoice tau. We are defining one abstract method, that is save. Now we are creating class for database operation, and we are creating class for file operation, and we are implementing the same interface from both, and we are overriding the same method and writing the logic to save invoice to DB and save invoice to file. I hope you got this 2 point as of now. And let's go to the other one. L stands for Liskov Substitution principle. This is little bit complicated but very much straightforward. So Liskov Substitution principle says subtypes must be substitutable for their base type. Let's say we have interface of vehicle. It contains two methods. One is turn on engine, and second in increase speed. So what motorcycle class is doing is implementing vehicle interface, okay, and overriding the turn on engine. What turn on engine is doing is just setting the boolean flag true. Is engine on? Yes, engine on. And void increase speed method is doing, it is incremented speed by 10, which is fine. But now what we are doing is we are creating cycle class which is extending vehicle, and we need to provide the implementation for both method, right? Turn on engine and increase speed. But while overriding turn on engine, we are getting the exception saying cycle does not have engine. While overriding increase speed, we are incrementing the speed by 5. So what it is doing is, let's say we are creating parent we are using the we are creating the object for cycle. So we all know that in inheritance, parent reference can be used to hold child object. Vehicle v is equal to new cycle. Let's say we are creating first motorcycle object first, and we are calling v dot turn on engine and v dot increase speed, which is both are found, both are having the same both methods are having the implementation. Now if I will create an object for cycle and we are calling turn on engine, and we are turn on engine is not there, right? Because it is saying exception, but increase speed method is fine for this case. So this is what Liskov substitution saying, that subtype must be substitutable for their base type. When you are extending one class from another, then the scope should not be narrow it down. Fourth principles is I stands for interface segmented principle. What does interface segmented principle saying? Interface segmented principle saying interface should be such that client should not implemented unnecessary function or method which they do not need. Interface should be such that client should not implemented unnecessary function or method which they do not need. Let's say we have an interface which we are creating restaurant employee. Restaurant employee contains three methods. One is cook food, second one is wash dishes, third one is serve customer. Now my client is waiter. What waiter is doing? It is implementing restaurant employee. Now my client, which is waiter, the responsibility of my client is to give the implementation for all three methods, right? So whenever they are overriding cook food, they are saying this is not my job. Whenever they are implementing wash dishes, they are saying not my job. But when they are implementing or overriding serve customer, they are printing serving customer. So this is the violation of fourth, which is nothing but interface segmented principle. So your interfaces should be divided into segment in a smaller portion, so that your client should not implement unnecessary methods. Okay, so instead of restaurant employee, what we can do is we can create waiter interface which contain only the method which are applicable for our client waiter, that is serve customer or take order. What my client will do is my client will implement waiter interface and giving the serve customer implementation and give the take order implementation. Let's say we do have another interface, chef interface. The responsibility of chef is to cook food, right? So what my client chef will do, will implement my interface and give the implementation for this method cooking food. So your interface should be divided into a smaller portion, but it should have only those methods which are required for your client. This is all about I, which is nothing but interface segmented principle. Last but not the least, dependency inversion principle. In the solid, D stands for dependency inversion principle. Dependency inversion principle says your class should depend on interface rather than concrete class. Your class should depend on interface rather than concrete class. What does it mean? It means, let's say we do have an interface of keyboard which is implementing wired keyboard, which is implementing Bluetooth keyboard. We do have a one interface which is implementing by wired keyboard and Bluetooth keyboard. Similarly, we have a mouse interface which is implementing by wired mouse and Bluetooth mouse. Let's say my requirement is to create a class MacBook. We are defining what type of keyboard and mouse this class will use. So this is basically a hazard relationship of inheritance. So what I'm saying I'm using wired keyboard and wired mouse. So maybe in the future, let's say we want to use Bluetooth keyboard and Bluetooth mouse. So what do we need to do is we need to modify this class, right? So this is a violation of last principle, which is nothing but dependency inversion principle. So instead of giving this concrete class, we can give interface, right? We are giving interfaces in this class which has a relationship with MacBook, and whether we are passing wired keyboard or Bluetooth keyboard, the reference will remain same. That's why dependency inversion principle says your class should depend on interface rather than concrete class. I hope you like this video. If you like this one, please do subscribe and like the video. I I hope you will like it again. Bye bye.